going to start recording now since it is 2. So these are, I think I've shared with, you can look on Discord actually to see what the grades were last semester, the grade breakdowns. But apparently I have it back from fall 19, which is prior to COVID, but the grade breakdowns have not changed too much. So let's look at 2168 first, which normally is smaller classes. A was a 90, was above a 90. A minus was an 88, right? So if you got less than a 90 but got an 88 or higher, you got an A minus. There was nobody that was in the range to get a B plus in 2168 that semester. So an 80 or above was a B, right? And that's true for this class. B, if you get an 80 or above in your raw score, you are getting a B. Same with an A. If you get a 90 or above, you don't have to worry about there being an arbitrary cutoff for a minus score. The minuses are basically the curving up to an A. So here was a C plus was a 77 and C was a 70. We typically get much larger classes for 1051. So that semester we had A plus B an 88. Sorry, and A was an 88 or above. There really wasn't anybody. Apparently the cutoff point, there just was not a cutoff point for that. So I think I just gave everybody an 88 or above. There wasn't really a cutoff point for me to say difference between an A and a B. A B plus was an 87 or above. B was an 80. A B minus was a 77 or above. A C was a 70. And then I think there was one or two students who squeaked by, who got a 68 for a C minus. I really try to avoid giving C minuses, but this is basically when I see a student this is typically when I intervene on one student's behalf, where like maybe they crashed out during the final exam or something, right? And where otherwise they had fairly steady grades throughout, and the final exam was just, I don't know what happened, right? Maybe I was staring at them too hard, right? There was a book that I read at one point called "Surviving Your Stupid Decision to Go to Grad School," and it was full. And one of the things it had was a list of things you could do to mess with your students during exams, such as writing on the board on a 20 question exam, writing on the board, ignore question 93. And then when a student inevitably came up to tell you that there was no question 93, you said, excellent job ignoring it then. So other things to do were to tell students no food or drink during the exam and then pull out basically a 3-course dinner. But that ignoring one is one I have done before. It's fun. And most students figure out that it's a thing. So anyway, please do your best to come to the final exam on time. Please. It will be in here as opposed to your lab. I will make sure I note that, And fortunately, it's not too far of a run from your lab if you do mess that up. But I would say, and by the way, if you do have to run, that exercise is actually a great technique. So this is my final aside before we get going. And this is especially relevant because ADHD goes undiagnosed in a lot of people, especially women because it manifests differently in women. So there was a study I think was done in Brazil. This is like this was a sports education study, and they were looking at the effects of exercise. Now, first off, exercise versus medication is not a replacement for ADHD, right? The best treatment for ADHD is medication, but it's a matter of quantifying things, right? And the study was how much does exercise affect concentration? And we're talking getting your heart elevated at a specific rate, at an elevated rate for at least 5 minutes over a 30-minute period of doing exercise. So testing it on ADHD, our groups were testing it on ADHD children who are medicated, ADHD children who are not medicated, and control group of people who are not diagnosed with ADHD, right? And then it is testing whether you exercise, and then the experiment was, did you exercise beforehand versus not exercise before? We gave you a task in a video game that required concentration, right? And the results showed that for people with ADHD, children with ADHD who were unmedicated, exercise showed the greatest benefit for concentration. That doesn't mean they did better than the medicated children who exercise. I'm just saying that if you're not medicated, then that helps. But universally, exercise helped with concentration. So keep that in mind. Exercise is pretty good. Yes?
Even if you don't have any?
Yeah, it helps everybody. Yes?
So is running or walking better? Because I do a lot of walking. I don't think it can.
It's a matter of getting the heart rate elevated, even just for a bit. So even if you're speed walking or something like that, just simply getting the heart rate pumping. Running in for a small bit is beneficial. I'm a bit hypocritical because I don't exercise enough myself. I need to get back into it, but it does help. Exercise in general is the second healthiest thing you can do. Anybody know what the healthiest thing you can do is? Yes?
Eat healthy.
Eat close. Very close. Stop smoking. Stop the benefits of if you smoke and you stop smoking, the benefits of that outweigh everything else, but just huge amounts. So, yeah. I mean, that seems to be a thing that's less and less in this generation, which is good, but yeah. When I was growing up, smoking sections versus non-smoking sections in restaurants were still a thing. So that was a fun time. Yeah, that was a thing. All right, enough about that. Let's go ahead and get you what you were here for, which is going over the practice exam. Now, if you've had the chance to look over it, great. If you haven't, well, now is your chance. And I'm just going to throw this out there for the problem I put over here, right? When I say that this is hard, I do mean it was hard. It involved more moving parts in this than you typically have to do. So if you did try this one and couldn't get it, or you found it was really hard, that's because it was. It just involved a lot of things that I wouldn't do on paper, but again, that's why I do these things in the practice exam, because I get to be sadistic in the practice exam. Okay, so regular expressions. So I came up with a few of these. I asked ChatGPT to help me brainstorm these, but in the end, I'm like, these answers suck. These example questions suck. I need to change them up, and so I did. ChatGPT is pretty good like that, where it comes up with some really bad ideas, but I springboard them into really good ideas. Okay, and that's another good way to study. Like you can load ChatGPT or Gemini or something with my questions, and then say, hey, can you give me some more questions or directions on how to solve this? Those kind of things to help you study for exam are a great example of ChatGPT, because of course you can't use AI when you're in the middle of the exam. I mean, you could, but that would be cheating. And so that's testing you on a completely different skill set that I'm not actually supposed to test you on. So now let's go ahead and see A to Z. So let's go ahead and see A to Z. So let's take a look at this regular expression. A lot of these, it says, which of the following strings does the given regular expression match? Select all that match. I want to emphasize here that this is not this isn't a choose one out of all of these. This is choose as many are correct, right? So some of them are correct, some of them are not correct. So here we've got A to Z plus /D 1, 2. So let's think about what this gives us. The first thing is this part is this part is a capital letter. This part is a lowercase letter. The plus over here indicates that we are looking for one or more lowercase letters. So it is a number of letters. So we know this starts with a capital letter, and then it has some number of undercase letters. So right from that, we can pretty much discard a few without even reading the rest, right? It's got to start with a capital letter, so we can scratch these out, right? Next, it says it's at least 0 or 1. It's at least 1, not 0, 1. At least 1 lowercase letter. So one uppercase letter followed by any series. So it's like a name or something. Then a /D, 1, 2. So /D is any number, and 1, 2 means 1 or 2. Okay, it's an inclusive range. So if it doesn't end with a number, we can discard that because it needs to end with a number. So we can discard Waldo as well. All right. So Apple 59, that's a uppercase letter, a bunch of lowercase letters, and then followed by 1 or 2 digits. So this is good. We'd want that one. XYZZY4. Okay, so that's an uppercase letter followed by a lowercase letter, and then we have another uppercase letter, but that's not specified in our regex. It's uppercase, lowercase, not uppercase, lowercase, uppercase, lowercase. It's just one or the other. Waldo. We should have discarded that, I thought. All right, I hit Control-Z on that. So Fred, 9. That works because it's an uppercase followed by a bunch of lowercases followed by one number. Yes? Yep, because we look at X. X matches A to Z. Okay, it matches that part. Then Y matches the other way around. Y matches the A, Z plus part. But then as soon as we hit the Z, we're out of the A to Z plus, and we're into the /D. Right? It doesn't have, it's the A to Z, sorry, the lowercase A to Z plus means it's got to be a series of letters that are A to Z lowercase. Yes?
What is backslash again?
Backslash just simply says it's an escape character, meaning the next character has a specific meaning. So slash says, look at the next character, it's going to be a special character. D, okay, what's special about /D? It's a digit. Make sense?
So does it mean either 1 or 2 or no other digit?
0, 1, 2, 3, 4, any numerical value.
Would it have 1 and 2?
So this means, sorry, let me go ahead and write this over here. This means min, comma, max repetitions. So if I had A, it would do it somewhere between minimum number of times and maximum number of times. So if it was, for instance, if it was,
At least 1.
yeah, if it was like this, if it was 4 to 7, right, it would match 4 A's in a row to 7. It would match 4, 5, 6, or 7 A's in a row. So anywhere between and so you know. So the rest of these are, sorry, this one is good. This one is good because they are uppercase, bunch of lowercases, and then numbers. And then finally we have B4Z54. This is no good because it's got to be uppercase, it's got to be the uppercase stuff, the lowercase stuff, and then the number for this specific example. So I wish there was a way to erase everything here. I'm sure there is. But the best I can do is hit it with the Control-Z. So our final answer is Apple. Yep. And you just fill them in however you want. Check marks is, X marks is. Just, differentiate between what is good and what is bad. The default way is to fill in the bubble. Okay. Now we've got colors. We've got COLO, U star, RS star. Okay. So this is to remind you what the clean star means. It means if I have so let's just grab it from the U. U star means 0 U's, 1 U, 2 U, 3 U, 4 U, 8 billion U's. Those are all good. It means at least 0 U's. We could have none, or we can have as many as we want. So, same with the S. That means we could have 0 or as many as we want. So, this works because, great, that is that's colors, right? That's one of each of the letters, including the optional ones. Color, sure, COLOU star means any number of U's followed by an R, and any number of S's. 0 is any number, so we'll take it. All right, COLOUOUOUR, color, no, that doesn't work because the star only applies to the U. So, what would the regex look like if I was looking for this one? It would look like this, believe it or not, COLOU, parentheses around the O and U, star, R. Right? You can group stuff together like that with parentheses. But this one doesn't match because it's repeating the O and the U, not just the U. Okay. COLOURRRRR. This one I find to be a decent good one for multiple choice because remember, the star is for the preceding character, not for the character that's after. COLORRS. Again, same kind of deal. Now we've got colors. This is just simply without the U, but with the S. That's fine, right? Because we can do COLO, any number of U's, so no U's, and any number of S's, and any number of S's. S is fine. And then the next two are, no, we don't check those either because that's without the vowels and in reverse. Those are typically would be selected by a student who is panicking and has no idea what's going on. Okay, and if that is you and applying to you, all right, take a moment, scroll back over to here where I typically write "don't panic," so follow that instruction first, and then read the rest of this page because it has things like what the clean star. Let me go ahead and check out. Let me pause for a second. Right, so if you forget your cheat sheet or forget things on your cheat sheet, check mine. Now, part 3. I love doing this for questions because I'm lazy. Part 3, for the above regex, how can we modify it so it only matches the following strings? And you can expect to get a question of like this pair on the exam where I give you regex, give you stuff to select, and then I tell you, hey, how do we change it so that we match these and things instead? Okay? So how can we modify it so it only affects the following? Color, colors, color, and colors. You can either give me an actual regex or you can simply say, replace the, and again, the emphasis is on the only matches the following strings. And we could just simply do COLOU question mark RS question mark, right? So the S gives us, so here what are we looking at? We're looking at the word color with both the American and the Commonwealth spelling, okay? And then also the S is optional to let us know whether it can be plural or not. Okay, we went over this one last time, but I'll do it much quicker this time. Which of the following strings does the given regex match? Select all that apply. 1 star, 0, plus 1 question mark. I am very happy to say, for your sanity, again, and I did this in my data structure class as well, that I don't like to give like things where you have to say 1, 1, 2, 1, 3, you know, and so on and so forth. I don't like you have to count numbers with numbers. I prefer you to count letters and stuff like that. So here we can say any number of 1s followed by at least 1 0 followed by an optional 1 followed by a 0. Okay? So part of what we know about this is that it needs at least 2 zeros. Okay? So we know that this won't work. So we can just simply go through at the beginning and kind of knock those out. Right? It needs at least 2 zeros. So if it doesn't have 2 zeros, we're not interested. Okay? Next, let's see. We know for those zeros, we can have a single 1 between them. You know, we have some amount of zeros. Right? We have some amount of zeros followed by optionally 1 followed by another 0. 0 on the end is mandatory. All of them end with 0, great. So, 0, 0. So, any number of 1s, that's fine, 0 is any number, followed by some number of zeros, that's 1, 0 over here, followed by an optional 1, followed by a 0. So, this is good. 1, 0, 1, 0. So, we have 1, any number of 1s, cool, followed by at least 1, 0, yep, followed by an optional 1, followed by a mandatory 0. That's also good. Any number of 1s, this next one starts, this one over here starts with no 1s. That's any number, at least 1, right? 4 zeros is at least 1, followed by an optional 1, followed by a mandatory 0. 0, 1, 1, 1. Well, we've got a 0 and a 0, and we can have 1, 1 between them because it's an optional 1. This would be fine if it was 1 plus or 1 star. But over here, it's question mark. So that is no good. And then 1, 1, 0, 0. Any number of 1s followed by at least 1, 0, followed by an optional 1, followed by a 0. So this one's good. So the answer is 1, 2, is 2, 3, 4, 1, 2, 3, 4, 7. So the answer would be this. Describe what the above regex is looking for. I've said it a number of times, which is at least, 0 or more 1s, followed by at least 1 0, followed by an optional 1, followed by a mandatory 0. All right, now we get into some code. The rest of the exam is pretty much going to be coding, and that's true on the actual exam itself. Although this one over here, we have regex as well. Let's go ahead and take a look. Exam 3 review.py. All right. This one is similar in difficulty to some of the other ones I've had on exam 2, I'd say, which is good. Although I do have a mistake, which is that I needed to comment out this bit. Okay. So here, right, this one is big sentence. I introduced it last time. Given a list of strings, return a string that takes the biggest word from each of the individual strings in the list and combines them together, separated by spaces. See the example. There's no time left. So cute. Look at the doggy. Becomes there, cute, doggy, because those are the biggest strings in each of those. So, there are ways, I think, to do this in one line, but it requires you to be okay with making completely unreadable code, and I don't like that. You'll get a hint of that in the file reading question, where I gave you a magic function, and I will be going over that magic briefly because it's useful information to know. Okay, so here what we've got is a sentence, and we have an output. We want to combine them into one single sentence of the biggest words in it. So we're essentially doing a running sum, but with strings, which means we've got output is equal to this, return, output. Okay, next. We need to iterate over each of these sentences. So for sent in sentences, okay, for each sentence in our collection of sentences, we got to get the individual words in order to work with them, right? And in these problems, I always give you it easy without any quote unquote easy, in the sense that I'm not trying to mess you up with any additional punctuation or stuff like that. That's nonsense that my 2168 students have to deal with. Right here, you can just assume that it's these. And still, the first step would, even in those cases, the first step would be splitting by spaces, because that's how we tell one word from another in English. Caveat with like dashes and stuff like that, but for the most part, it's spaces. So words is equal to take our sentence, and then we dot split, not dot splut, dot split over spaces. A lot of words. Okay, we split over spaces. I don't know why I'm finding that suddenly really amusing. Okay. Now that we've got our collection of words, we got to figure out which of the words is the biggest. So we can say biggest is equal to, and we can either set it to like words 0, or we could just set it equal to blank. Either works, right? But we got to figure out what the biggest word is. Now you might be trying to get clever and say max words, but let's see what that does, right? Let's see. So let me show you what that does in idle, right? Because max gives you the biggest thing, right? So let's see what asking for the biggest thing is here. Max of and banana and pizza store is. Get your pizza store. Interesting. All right, I would have sworn that was going to give me the and, because that alphabetically is first. And again, let me see. What about max of and can? Give me can. What about the max of, now let's go ahead and take these. Let me take this one and drop it into a list and see if that changes things. Because I could have sworn it gave it to me alphabetically at some point. No, okay. So it does what you'd expect it to do. It gives you the biggest string. So that is one thing you could do. Yes?
How is can bigger than n?
Can is bigger than and. Can comes after and. Oh, right. There we go. Give me a second. No. I think I figured out what I'm doing wrong here. I think my initial collect. Yes, there we go. So it does work alphabetically.
Your min would get n first.
Min would get and max gets you zoo. No, it has nothing to do with the size and everything to do with the fact that Z, that alphabetically Z is coming last. Yes.
Strange question. What if you did like max, int, and then the list?
I don't know.
I
let's see, give me a second. Max. So here, what you're looking for is, what you're thinking of is this. And this is where we start getting into advanced magic, I think. I think you're thinking of this.
No, I was thinking before the list, like its own separate,
That's what you're...
max, parentheses, int, and then the rest of the parentheses of the list.
So-
I don't think it's.
No, what you're looking for is this, where you say key equals length, and the key is a way to specify a function you want to use to evaluate it, each item in the list. Here, you're saying the key is equal to the len function. This is where I'm starting to talk about that advanced magic I was alluding to earlier. Okay? So let's go into that for a second. Advanced magic for a second. Okay? We are about to get sidetracked here, but it's a good sidetrack. Def f of x. We're going to make a math function here. Or, no, I'm going to actually call it, give it another name. Double x is going to return 2 times x. Make sense? We're just doubling the number. Print double 5, right? Gonna do nothing, and that does exactly what you would expect on the 10. It gives you 10, right? No surprises there, nothing up my sleeves. All right. So if you're coming from a C base, so if you're coming from C, C++, Java, what you're about to see is an unholy abomination, which is beautiful. It's beautiful unholy abomination, which is that functions are first-class citizens in Python. What do I mean by that? Well, I print double, and it tells me it's a function named double. Which means, since it's a first-class citizen, I can do things like this. F is equal to double. F of 10 is equal, and print that out, 20. All I did was create an alias for the function, right? I just gave it another name. It's a first-class citizen. I can store it in a variable. Why can't I do that? Because we've been dealing with the only things that functions can take in. The only things are, because we've been operating under an implicit paradigm that our verbs only take in nouns and adjectives as arguments, right? But verbs can take in other verbs as arguments. Why not? Why not? Why can't a verb take another verb as an argument? And why can't a noun store a verb? You know, a gerund, so to speak. Now, it gets even funnier because we can do something like we can do def do f, which takes in an f and an x and returns f of x. All of this is completely unnecessary for your success in future classes. And this class as well. It's just getting into this, to how flexible this language is. So I can do something like so I can print do f double and 10 and get the same result. Where I'm saying, hey, do f takes in a function and a variable, and I'm saying do f of x, whatever that f of x is. This is very useful if you start doing your math homework on this kind of stuff. And that gives you 20 because we're passing in the double function and the 10 as an argument. So, yes, you can do something like for over here. So what we can do over here, we'll just comment this out for right now. You can do something over here like biggest is equal to max words, key is equal to length, but I don't expect you to remember that in the middle of an exam. Right? With exams, you definitely want to use the tools you're most comfortable with, which means that we set our biggest equal to a empty variable, and what we're going to do is manually find the biggest, which is simply saying for word in words, for each of the words in our list of words, if length of word is greater than length of biggest, biggest is equal to word. Right? That's how we manually do that. We manually iterate through each of them. Now that we know what the biggest is, we can say output plus equals our word. Sorry, not the word, but the biggest word we found. Okay? And this will actually get us pretty close to the answer. Right? If we do print big sentence and then give it this argument, which I need to fix up a bit because we're getting that quotation mark problem from taking from a PDF where the quotation marks get a bit different. And we get very close to the final answer. Oh, parentheses was never closed. What do you mean parentheses were never closed? Oh, yeah, the print parentheses were never closed. We get there, cute doggy. Now, so this would probably get you 9 out of 10 points because it's an A answer. The difference is that in our output we do need to space them out. So output is equal to this, and then we get there, cute doggy. And if we care about this extra space in the end, we can chop that off using slice, but that's fine. Everybody follow? Right?
Why is it being able to alias functions so important and unique?
Well, it's not necessarily unique about Python. Java did eventually add it with predicates and stuff like that. But what's unique about it is you'll see it in the code I have for the hard problem on the exam, where I give you a function that's already filled out with some of that magic.
And what if you create a function, alias it, then create a new function down later on, and name it as an alias of the existing function?
That would replace it, I believe. It goes in order, I believe. It reads line by line, so okay, I believe. All right, this one I think is very good of kind of very representative is the word I'm looking for. Very representative of the kinds of questions I would ask. Write a function called make username that generates a username for a given name as demonstrated by the examples below. You can assume that names are of the format is either first name, last name, or first name, middle name, last name. We need to do this because names are complicated. Names are actually very complicated. Oh, come on. I was trying to be nice. This is what I get for trying to be nice. Falsehoods programmers believe about names. People have exactly one full canonical name, one full name they give by. People have exactly n names for any value of n. People's names fit in a defined amount of space. People's names do not change. People's names are written in ASCII. They are not always written in ASCII. If you have an umlaut, then suddenly you're not written in ASCII anymore. People's names are case sensitive. They are case insensitive. Depends on the person, right? Some people's names have prefixes or suffix, but you can safely ignore those. People's names do not contain numbers. People's names have an order to them. Picking any ordering scheme will automatically result in a consistent ordering among all systems as long as both use the same ordering scheme. No. People's names are no. My name will ever have to deal with names from China or Japan or Korea or Ireland, the United Kingdom, the United States, Spain, Mexico, Brazil, Peru, Russia, Sweden, Botswana, South Africa, Trinidad, Haiti, France, the Klingon Empire, all of which have weird naming schemes in common use. The Klingon Empire thing was a joke, right? These are all, it's a very fun, thing. Names are actually very complicated, and Like for instance here, people are assigned names at birth. That's an assumption. That is not true. Not at birth, but pretty close, right? Okay, within a year or so. 5 years? You're kidding me, right? No. Some cultures, in some cultures, it is bad luck to assign a child a name before a certain time. Don't want to draw evil's attention to him. So, names are really complicated, so that's why I have this caveat over here. It's actually these assumptions programmers make, or falsehoods programmers believe list is actually pretty good. It's a fun stuff. It's a fun read. Okay, so over here we have we're assuming that the format is first name, last name, or first name, middle name, last name. Okay, so over here we have a few examples, and what we're doing is we're making a username, and I say follow the input output. Okay, so if I give you Andrew Rosen and 12, you're going to get AR12. Alan Turing and 5, you're going to get AT5. If I give you Andrew Benjamin Rosen 3, you're going to give me ABR3. And if I give you Andrew Benjamin Rosen 104, you're going to get ABR 104. So in other words, what are we doing? We are creating a string where we take the first initial of each of the names, and then we are adding whatever number to the end. Not too complicated, just relies on us splitting again. So make username, name, and end. So this is actually not too bad. We're going to say username is equal to empty string for right now, and return username. We may not even need to define it in advance, but it's always useful to do so, I find. Okay, so we know that given a name, it's going to be some parts. Split into some parts, and we split it by spaces, right? Name got split on space, and that gives us parts. And it's either going to have 2 parts or 3 parts. And honestly, it doesn't actually matter how many parts it has, because this code will work regardless, which is we just simply iterate through each part and get the first letter. For P in parts, get the first letter by saying letter is equal to P0, and username plus equals the letter. Now, there is one. Now, if I follow what I'm doing, I haven't finished it yet, but if I continue doing the way I'm doing, Andrew Benjamin Rosen wouldn't give me ABR 104, but it would give me in shouty case, ABR 104. Okay, so we want to actually, what we'd want to do in this case is actually say P, either here P dot lower to convert it to lowercase, or maybe over here, before we split it, we would say name is equal to name dot lower, but anywhere would qualify us as getting it into the right case. Is this something you have to really worry about? If it's on the rubric, if I give you a rubric, it would probably be on the rubric with like a 1-point entry. Ensure that everything is lowercase, right? And you'll see a good example of the rubrics on my hard problem, because I made sure to give you a good rubric for that one. Part, 4P in parts. So we could take the username, add the letter, and then we would do username plus equals strn to get our number. If you forgot the str, you'd be safe in Java, but in Python, I'd probably knock off a point, because that would cause an error if you didn't. Again, there's a lot of ways to get a almost perfect answer and lose a point. It happens, but that point isn't going to make or break you if you're getting it almost completely correct. All right, back to regex. How would you write a regex that matches the sentence where the first word is either Alice Bob, or Carol, the second word is either eats, pets, or throws, and the third word is apples, cats, or baseballs, and the sentence ends with a period. It should be case insensitive. So there's a couple different ways to do that, but what I would do is I don't have a question like this on the exam, but it's still good exercise because it's reminding you about the bar. Bar is used for or. So we could say something along the lines of, let's go ahead and copy this actually. So let's see. Let's look at our question. This is from the Automate the Boring Stuff in Python textbook, by the way. How would you write a regex that matches each of the following? Where the first word is either, and let's view, and come on, do you not do Alt-Z? No, okay. How do you write a regex that would match where either the first word is either Alice, Bob, or Carol? The second word is eats, pets, or throws. The third word is cats. Is either apples, baseballs, or cats. So, and the sentence ends with a period. The regex should be case insensitive. It must match the following. Alice eats apples. Bob pets cats. Alice throws baseballs. Alice throws apples. Bob eats cats. But not the following. RoboCop eats apples. Alice throws footballs. And Carol eats 7 cats. So, a lot of violence against cats here. So this regex would probably look something along the lines of, right, if we were trying to match something, let's assume we were matching. At first I would mention that we could use re dot, I think it's re dot I for case insensitive. Is it re.I? Insensitive. So, re Python. Because it's saying to make a regex. It's not saying in any particular language. But there are ways to make things case insensitive generically. Let's go ahead. And there's, as you can see, there's other things like back references onto groups, which is its own. These things get powerful. Okay? /Z matches the end of a string. Interesting. So, re.I. Yep, re.I is short for re.ignore case. It says corresponds to inline flag, and that's apparently regex for this is apparently regex for ignore case. But honestly, I don't like including that stuff in my regex. So, but we can do something like this. Alice or Bob or Carol. And then we have to group them together because we're saying it's one of those, followed by a space, followed by eats or throws or pets, followed by another space, followed by apples, balls, cats, and then the trickiest part is actually the period at the end, which you need to remember. Period is any character, so to match a period at the end, we would do /p. I'm sorry, /p, /dot, right? This matches any character. Escaping it means I want just the period. Yes?
You typed case
insensitive. All right. Still doesn't look right. but apparently it is. All right. So now let's go on to the next question. All right. Write a function that, given a file name, creates a new file that with the exact same contents as the original file, but with all phone numbers such as 123456789 replaced with private. So we are going to start out with the generic solution and then modify it, because again, with the rubric, the way the rubric will work with reading and writing files and this re.sub, I believe the regular, I think you get basically 8 free points. The regex is either worth 8 or 12, depending on my rubric. So, but regardless, there's lots of free points to be had here. So, and again, this is a question that will be on the final exam. I think on the actual exam it's worth 20 as opposed to 10, but point being is that there are a lot of free points to be made here. Okay, so let's look at this. Right? Write a function given a file name. Given a file name, creates a new file with the exact same contents as the original file, but with all the phone numbers replaced with private. So let's go ahead and say that. So given a function, def function, so let's call it replacer. Given a file name, creates a new file with the exact same contents. So we got to read this file, we got to modify it, and then and then output it. So what we're going to do is we got to first open this file. So text is equal to, we'll go with data is equal to open. File name, read. All right. We're going to open this up, and then we're going to do text is equal to data.read. This is one of the few cases where we like to dump the entirety of a file into a single string as opposed to going line by line. Okay. Also for this one, you can assume that RE is imported, right? I'm not going to take off points if you don't call import RE. Make sense? So data is equal to open. Text is equal to data.read. All right. Then what we need to do is we need to replace all instances of a pattern. And we're just going to say replace me. Right? We're going to find this pattern. I did not import it, but I will here. Import RE. RE.sub is the function that we want, which takes in a pattern, replaces it with, in this case, we want to replace it with private, looks for all instances and of this pattern and replaces them with private in text. And if we need to double check the way that works, because I always like to do it, regex.sub, right, to replace the, yeah, this is an other way of doing it. Make a regex object, use regex.sub, thing to be replaced target text. So this is fine. Yep, this is the right order. re.sub, pattern, private text, pattern, private text. That will create a new string, output text. I'll just call it output. Our output is this. And now we just need to add that to a file. So what we're going to do is we're going to say out file is equal to open, and then not sure what we should do with the file name. I never specified what we would call it. We could call it whatever we want. Maybe we could call it answer.txt here, right? Or maybe I should say, or maybe I'll call it file name. Yeah, I'll just call it answer.txt. It doesn't really matter. Or we can just be lazy and say out file name, right? Let the user define it. Right? Either way works. We'll go with one that's simplest, answer.txt. But we give it some answer. We need to give it to some output, right? And write that to a different file, right? Write a function that, given a file name, creates a new function with the exact same contents as the original file. But everything has been replaced. Once we create our magic pattern, everything will be replaced. So and then we write it out file, and then we say out file dot write to write to a file. Very simple over there. What do we want to write? We want to write our output, and then out file dot close to close the file. Right? So what are the variable parts of this? Well, if I give you an output file name, then you'd want to throw that as an argument there. But otherwise, the only real part of this that ever changes is the pattern. Okay? So if you have this on your cheat sheet, this is, again, easy. Or if you just have it memorized like me because you've done it enough. All right, pattern. So what is our pattern? We're looking for a phone number. Phone numbers are weird. Let's go ahead and see what we got here. So phone number is open parentheses, the area, so a US phone number, I should say, is open parentheses, 3 digits, followed by a closed digit for the area code. So open parentheses, 3-digit, close parentheses. Then a space, then 3 digits, then a dash, and 4 digits. So let's start at the beginning. So as we saw earlier, doing parentheses has its own kind of special usage for grouping. So those parentheses are special characters. So what we'd need to do is escape them. If you didn't escape them, again, it would be a minor penalty, like 1 point we're talking about. Okay, so we escape those. Then we have 3 digits, exactly. So we could do /d/d/d/d. Oh, and put an R here for regex. So R. So we'd start like this. Slash, we've got 3 digits surrounded by parentheses. Same as what I just deleted. Then you'd have a space. Then you have, let's see, what do we have next? We have 3 digits, followed by a dash, followed by 4 digits. And that's it. Now, there's other ways to do this one. We could easily have said something like this. We could have done D3 over here, D3 over here, and D4 over here, right? We could have said 3 digits, followed by this and this. Yes? You had a question?
I'm sorry, my mind was
No worries. So we could specify the number of digits we needed, which is pretty useful. Now, what if we wanted to match file? Now, what if I added to this and said, because on the exam I would probably add a bit more, or at least not on this exam, but on the final exam I typically add a bit more to this, such as, what if? How much time do I have? Yeah, we'll get to this one on Thursday. But what if I wanted to add to this one and make it a bit, and make What if you don't have the parentheses? What if the parentheses are optional, I should say? Because there's multiple different formats for telephone numbers. That's something we'll tackle on Thursday. But for now, this is good. I need to make sure I have time to do the next question, which I mentioned was the hard one. All right. There's additional practice for regex over here, which is regex golf, where basically you're trying to do match everything in the smallest possible regex. So in other words, you're trying to get down to par, like golf. Anyway, this one is the hard one that I mentioned. So given a file composed of lines of positive integers, so I know when I say positive integers that instinctively makes some students flinch, but that's just a way of saying positive whole numbers, right? Not fractions. We're not dealing with fractions or floating point numbers. It's just the nice, friendly, regular counting numbers. Lines of positive integers separated by commas. Return the sum, so a file that looks like this, right? It's just numbers separated by commas, regular plain old numbers separated by commas. Return the sum of all numbers in the file that are adjacent to its square root. For example, given this file over here, we're going to yield the answer 73. This is because of this. 25 is adjacent to its square root, which is 5. So, and 4 is adjacent to 2, which is its square root. Make sense? Similarly, 36 is adjacent to 6, so we add 36, right? 25, 4, 36. Each of these ones are adjacent to each other. So remember the square root of 1 is 1, because 1 squared is 1. So we've got 4 ones, so we've got 4 ones to add here. And then 4 is next to 2 in this line. Okay. Put your code on the adjacent page. So what makes this one particularly difficult is the fact, not that we're dealing with square roots. Square roots are easy. Why? Math.squirtx gives you a floating point number, which is the square root of x. I know it's square root was SQRT because that's the way it's always been. Okay. So, no, the tricky part is identifying if a number is adjacent to its square root, right? That requires two parts. Figuring out what the square root is, which, again, we mentioned that's easy. And then the other part is comparing it to the adjacent items. So here's a rubric, which, again, rubrics double as your hints. Reading the file. And I typically come up with these rubrics by thinking of the steps that I need to take to solve the problem. Reading the file, iterating over the lines in the file, converting the line into an integer, doing a running sum, identifying which numbers are adjacent to their square root, ensuring no index out of bounds, returning the running sum. So here's how we're going to do this. We are going to read the file, iterate over the lines, convert the lines into integers, right? Doing a running sum, and then we're going to skip these other parts. We are going to add all the numbers, not just the ones that are adjacent to the square roots first. And then we'll work on narrowing it down. Because if you notice, and you think about the points for a second, if we do everything but identify which ones are we need, and adding only those, we get half credit on the problem. So that's fairly straightforward. Now let's see what we've got here. Now, this is what I was mentioning was the magic. And if I don't have time, you know what? I think I'll make sure I don't speed up and I go over with plenty of time for this. And if I have to, I will review the next problem on Thursday because that gives us plenty of time still, the Monte Carlo stuff on Thursday. So let's take a look at this. This is the magic line I was talking about when I mentioned earlier about evil magic, evil Python magic. Because this one was one of the things I'm like, this is the part I don't want you to have to think about. Now, this takes, now if we look at this, this says line to ints, line, Magic function that turns a string into a list of integers. For example, 1, 2, 4, 2, 4, that line, that string of numbers becomes the list of numbers. And let's take a look at what my magic is. It is list the map of int to line dot split. It's a lot in there, right? But this is a one-line wonder. Let's go ahead and see what it does first, and then I'll digest it for you. Okay? Ooh, interesting. Interesting. Idle. All right. So what's it called? It's called line. Let's create my variable. Line is equal to 1, 2. So we might have a line like this, and remember your lines are strings, right? If I take this magic bit of code that I've written and run it, whoops. Right, so line split. Taking this magic line of code. Those errors are because I'm copying from a PDF, not because of anything. There we go. So you see my input was 1, 2, 2, 3, 4, and I get the list 1, 2, 2, 3, 4. So let's digest this one bit at a time. Line dot split, right? Line is this, gives me a list of strings, right? Just like we do before, right? Right, we see this? Again, you don't need to know this for the exam. I'm just going over it for completeness sake. So 1, 2, 2, 3, 4. Took this. We've seen how split works before, right? If we do apple, banana, and banana, right? And we do dot split on that with no argument, it's going to split on spaces. And we see it just creates a list of strings. And that's what we've done over here. But now, because we're working with numbers, I'd like to convert them all into numbers, please. Okay? So this is what the next bit does. Map int to split. And this is where I was talking about functions being first-class citizens. Map is a built-in function in Python. It's pretty advanced compared to all the other stuff that we've been doing, because what it does is that it takes in a function as an argument, right? That weird thing we were talking about. And what map says, it says, given a function and a list, do the function to all the things in the list. So here, what I'm saying is, given a list, right, because this produces a list, here's that list, do int to all the things in the list, because I'd like to convert them all into integers all at once. Now that's going to give you a map object, which is something you typically loop through, like you do a for loop over it. But rather than doing that, I am just simply saying, rather than looping through it, I'd like to turn that into a single list and just do. Again, I'd rather take this all and give it the list to basically turn it into a list. You aren't expected to reproduce this for an exam. I've only just mentioned this to you, but yes.
Is that like numbers, characteristics, like the AAD of the object?
Sorry?
Is that the AAD of the object, or what is that?
Yeah, it's like the memory address of that object. And so this is a very powerful function because you can convert things all at once, right? You could easily write a function to double all the things in a list, do it all in one line. It's very powerful, this map idea. But what I'm sacrificing here by doing this is I sacrificed a whole bunch of readability, which, mind you, when I'm giving you a paper exam and want to give you as much space as possible to work, isn't the worst idea, which is why I just simply call it magic. Sometimes you just need to know what it does, right? And I tell you what it does. And that's just simply to make this point a bit easier to do. So let's go ahead and take both of these. Sum of adjacent squares file name. So we know how to do this. Data is equal to open file name R, and then lines is equal to line. We can either do a for loop over this data, or we can say lines is equal to data dot read lines to read them all. And then we need to do a running sum total, which let's go ahead and remember to return that at the end. Return total. Okay. And now what should we do? Well, we want to add up all of the numbers in the line. Ignore for the second the requirement of squaring adjacent numbers. I think with the amount of time we have left, I'll also save that for Thursday. Give you the chance to work over this one on the next couple days. So, so what we need to do is we've got this line for line in lines. So for each line in our collection of lines, we're going to go ahead and say line, or I'm going to say nums is equal to line to ints. I'm going to pass it in because otherwise we'd have to spend time converting, and I figured that was just one step too many. Right? Convert all the integers, this line into a list of numbers. Then for each n in nums, total is equal to total plus n. So with what we've written, we've taken the problem and we've arbitrarily made an easier version of it. Well, not actually arbitrarily, if we think about it. We followed the rubric and skipped the harder parts of it, identifying which numbers are adjacent to their square root and ensuring no index out of bounds. Right? We skipped those two parts of it. And as a result, we will get 10 points on this question as it stands. Right? How do we do that? We know how to read a line. We know how to do a running sum. We took that line. We got each of the numbers from it, right? Or converted them each to integers, and then got each number from that list and added it up. Okay? Not too hard here. Not too much. The next bit is the tough part, which, again, with the amount of time we have, just 4 minutes left, I'm not going to do this here. But what do you have to do? Okay? So what we do have to do is two parts. First, check the index beforehand to the index, check for given a number. Check the index before this number and the index after this number to see if either of those are the square root of me. Okay? The second thing I have to do is, since I'm checking the number before, the index before me and the index after me, I have to make sure that neither of those will give me an index out of bounds error. Okay? Which is its own thing. But I gave you that reminder over here in the rubric, right? For this card problem over here, which I believe we've done in class, I tell you, generate the 3x3 grid, select your cards, check if it's win or loss, and then I give you a rubric for these things. So again, I try to be very straightforward with the rubrics. The rubrics are there to help you if you are blanking on a problem. Okay, if you are blanking on a problem, just kind of march forward with it. The problems are often easier than you think they are. That's a lot. Think back to the hurricanes tracker assignment. That one looked crazy impossible at first because it involved graphics. But then you realize it was just a matter of reading the file and telling a turtle to go to a location, right? Was actually a lot easier than it appeared to be. So don't despair on this. All right, so I'm going to go ahead and stop recording.